Welcome back to This Week in Biochar, where we, as always, take a look at some of the most popular articles of the week from Biochar today.
Always an exciting time, right?
Absolutely. So let's jump right in. This week, we've got a really fascinating mix. We're talking about a new facility opening up in South Africa. We're going to dig into all those different types of carbon materials, biochar and charcoal, what's the difference? And then we're going to look at some really exciting research highlighting, biochar's potential to actually address some major global challenges.
Yeah, it's a packed lineup. I'm excited.
Me too. So first up, let's head over to South Africa, where they're getting ready to launch their very first large-scale biochar facility early 2025.
That's a big deal.
Yeah, absolutely.
Yeah.
The company behind it is called B10 Char, and they've got some pretty ambitious goals.
Yeah, what are they looking at?
Well, they're aiming to convert about 22,000 tons of organic waste into 7,000 tons of biochar every year. And on top of that, they're projecting to remove something like 15,000 tons of CO2 emissions just in that first year alone.
Wow. It's like they're almost single-handedly tackling, waste management, carbon emissions, and supporting agriculture all in one go.
It's true. They're really taking this whole reverse coal mining thing seriously.
Reverse coal mining. Now that sounds interesting. I haven't heard that one before.
Well, it's essentially what we're talking about, taking something that we consider waste and turning it into a valuable product. And they're taking it one step further with this pre-charged biochar concept.
Pre-charged biochar. What does that even mean?
Well, from what I understand, they're basically enriching the biochar with nutrients and microorganisms even before it goes into the soil. So it's like giving the soil and the plants this extra boost right from the get-go.
Ah, like a supercharged biochar. That's pretty clever, especially for areas where, the soils are already depleted or lacking certain nutrients.
Exactly. And it sounds like they're really investing in this facility, too. They've got a refurbished 4-hectare site with modern offices, a lab, employee accommodations, even those high-tech automated kilns coming in from China.
Oh, wow. They're going all out. It seems like they're really setting a new standard for the industry.
Absolutely.
Yeah.
Now let's shift gears a bit and talk about something that I know can be a little confusing.
Yeah.
The whole world of carbon-based materials. I mean, there's biochar, charcoal activated carbon. It can get a little overwhelming.
Yeah, sometimes it's hard to keep it all straight.
Right. So Biochar Today actually had a really great article this week that breaks down all these different types of carbon materials. Biochar, charcoal, activated carbon hydrochar, even carbon nanodots.
Oh, wow. That's a pretty comprehensive list. They covered all the bases.
They did. It was great. And they did it in a way that's easy to understand.
Huh.
They use this analogy of like imagining them as members of the same family, each with their own personality and their own job.
I like that. Makes it a lot less intimidating.
Right. So let's start with the star of the show, biochar. What's the rundown on this one again?
So biochar, it's produced through this process called pyrolysis, where you basically heat up organic matter in a low oxygen environment. And what you end up with is this stable form of carbon that can be added to soil to improve its health and basically store carbon for a really long time, potentially hundreds or even thousands of years.
That's always mind-boggling to me. Thousands of years.
Yeah, it's pretty amazing. It's like this ancient technology that's suddenly become super relevant again.
It really is. So
Yeah.
what about charcoal? How does that fit into all of this? Is it the same as biochar?
Well, it's produced in a similar way, heat and a low oxygen environment. But the difference is charcoal is produced at higher temperatures.
Oh, so the temperature changes the end result.
Yeah, exactly. With charcoal, you get this lighter, more porous material that's perfect for burning as fuel. Biochar, on the other hand, is all about soil amendment and carbon storage.
Makes sense.
Yeah.
So now activated carbon, that's another one that people throw around a lot. What's so activated about it?
Well, think of activated carbon as charcoal that's gone through like a super intense workout. It goes through this additional process called activation, where it's exposed to high temperatures and gases. And that creates a material with this massive surface area that's full of these tiny pores.
And all those tiny pores are what make it so absorbent.
Exactly. It's really good at trapping impurities. That's why you see it in water filters, air purifiers, even in some medical treatments to absorb toxins.
Like a little microscopic cleaning crew.
Pretty much.
Right.
Now, hydrochar is a bit different. It's not made through pyrolysis, but through something called hydrothermal carbonization. So basically, you treat wet biomass with high pressure and moderate temperatures.
Sounds a bit like pressure cooking.
Yeah, kinda. And while hydrochar can be used for energy and soil improvement, it's not as stable as biochar for carbon storage.
Interesting. Okay, and then last but not least, we've got carbon nanodots. What are those all about?
So carbon nanodots. They're these incredibly tiny particles with some really interesting properties. One of the coolest things is that they can fluoresce. So basically, they emit light when exposed to certain wavelengths.
Wow, that's amazing. What do they use that for?
Well, all sorts of things. Bioimaging sensors, even advanced drug delivery systems.
It's incredible how diverse this family of carbon materials really is.
It really is. It just goes to show you how much potential there is in carbon in all its different forms, and
Hmm,
we're only just scratching the
it's
surface.
pretty mind-blowing.
Mm.
Well, this deep dive into carbon materials has definitely been enlightening. Let's move on to our final deep dive for this week.
All right, I'm ready. What do we got?
We're going to look at a research review that's been making some pretty big waves. It's all about biochar's potential to tackle two of our biggest global challenges: climate change and agricultural productivity.
Oh, yeah, I've heard about this one. Isn't it making some pretty bold claims about biochar's ability to reduce CO2 emissions?
It is. The review, which was published in the journal Environmental Chemistry and Ecotoxicology, suggests a potential reduction of 62–66%.
Wow, that's a significant chunk. What's the science behind that? How can biochar have such a big impact on climate change?
What it all comes back to that pyrolysis process.
Hmm?
When we create biochar, are essentially locking away carbon in a stable form, preventing it from being released into the atmosphere as CO2.
So it's like we're capturing carbon before it can contribute to the greenhouse effect.
Exactly. And on top of that, biochar also plays a crucial role in enhancing soil fertility.
Yeah, how does it do that?
Well, think of it like a superhero for your soil. It improves soil structure, which leads to better water retention. It creates a more hospitable environment for beneficial microbes, and that all leads to healthier, more productive plant growth.
So it's a win-win, storing carbon and improving the soil at the same time.
Exactly. But there's even more to it. Did you know that biochar can actually act as an effective adsorbent? Meaning it can help remove pollutants from both water and soil.
Oh, yeah, I've heard about that. That's pretty amazing. How does that work?
It's all thanks to that porous structure we talked about earlier. Those tiny pores act like traps, capturing pollutants like heavy metals, pesticides, and excess nutrients, preventing them from contaminating groundwater or harming plants.
Wow, so biochar is like this multitasking environmental cleanup crew. It's incredible.
It is. The potential here is really inspiring. Imagine a world where we can grow more food while simultaneously cleaning up the environment. Biochar seems to hold the key.
It's definitely a vision worth pursuing, but of course there are challenges.
Like, what are some of the things we need to be mindful of?
Well, for one, we need to make sure we're optimizing production methods to ensure that biochar is being produced efficiently and sustainably. And then there's also the concern about potential contaminants in biochar derived from certain feedstocks.
Right, not all organic matter is created equal.
Exactly. And that's why ongoing research is so crucial. We need to refine application techniques, understand the long-term impacts of biochar on soil and ecosystems, and fully address those potential contaminant issues.
It sounds like there's still a lot to learn, but the potential benefits are enormous.
Absolutely. The possibilities are endless. But hey, let's not get ahead of ourselves. We've got a lot more to discuss.
You're right.
You know, it's interesting when you think about all these biochar applications, it really ties back to this idea of a circular economy.
Oh, absolutely. We're taking waste and turning it into something that can actually improve our planet. Enhance soil, health, capture carbon, even clean up pollution. It's a beautiful cycle.
Yeah, it's really a perfect example of sustainability and resource conservation in action.
Okay, so we've established that biochar is pretty amazing, but I think it would be helpful to maybe step back for a second and really break down how it actually works its magic in the soil, the microscopic level.
Yeah, let's dive a little deeper into those mechanisms behind biochar's benefits.
Okay, so let's say you're a farmer and you've just added biochar to your soil. What's happening down there at that tiny level?
Well, first of all, biochar acts as a physical conditioner for the soil. So that porous structure, it helps improve drainage in clay soils and increases water retention in sandy soils.
Ah, so it's kind of like a tailor-made solution for different soil types.
Exactly. It adapts to what the soil needs, but it goes beyond just the physical life. Biochar also has a big impact on the soil microbiome.
The soil microbiome. Remind me what that is again?
Sure. The soil microbiome is basically this incredibly diverse community of microorganisms that live in the soil. So bacteria, fungi, protozoa, all these tiny creatures that are essential for healthy plant growth.
Right, it's like this whole hidden world beneath our feet.
Hmm.
So biochar gives these microbes a boost.
It does. It provides a habitat for the beneficial ones, gives them a place to live and thrive. And it also helps to regulate nutrient cycling in the soil, making those essential nutrients more available to the plants.
So everyone wins. The soil, the plants.
Exactly. And when you incorporate biochar into the soil on a larger scale, It can actually contribute significantly to carbon sequestration.
Right, we talked about that a bit earlier. But can you walk us through that again? How does that work?
Of course. So remember how we talked about biochar being so stable? Well, that means the carbon that's locked away in its structure stays in the soil for a very long time instead of being released back into the atmosphere as CO2.
So it's like creating a carbon sink in the soil.
Precisely. And that can make a real difference in the fight against climate change.
You know, you keep mentioning pyrolysis, and I have to admit, I'm still not quite sure I fully understand it. Can you maybe explain it in a way that's easy to visualize?
Sure. Imagine you're building a bonfire. You've got your wood all piled up, you set it on fire. The wood burns, releases heat and light, and eventually turns to ash, right?
Yeah, that's a classic bonfire.
Now imagine if you could control that bonfire, limit the amount of oxygen that gets to the wood. Instead of burning completely, the wood undergoes this process called pyrolysis.
Okay, so instead of ash, it turns into something else.
Exactly. During pyrolysis, the wood is heated without oxygen, and it breaks down into different products: gases, liquids, and a solid residue. That's the biochar.
So it's like capturing the essence of the wood before it disappears into smoke.
That's a great way to put it. And by carefully controlling the pyrolysis process, we can actually create biochar with specific properties tailored to what we want to use it for.
Fascinating. So it's not just one product, it's like a platform for innovation.
Exactly. We can tweak the production process to create biochar that's optimized for soil health, carbon sequestration, even pollution remediation.
You mentioned pollution remediation.
Yeah.
How does biochar actually help clean up the environment?
Remember that porous structure we talked about? Well, those pores act like tiny traps capturing pollutants in the water and soil.
So it's like a natural filter.
In a way, yes, biochar can bind to things like heavy metals, pesticides, even excess nutrients, and that prevents them from leaching into the groundwater or harming plants.
Wow. So biochar really is like a multi-purpose environmental superhero.
It's definitely a versatile tool.
Okay, we've talked a lot about the benefits of biochar, but I think it's important to acknowledge that no technology is perfect. Are there any potential downsides or risks associated with biochar?
Oh, absolutely. It's important to look at both the pros and the cons of any new technology. And with biochar, there are a few things to keep in mind.
What kind of downsides are we talking about?
Well, like we discussed earlier, the feedstock you use to make biochar can actually affect its quality. Some feedstocks might lead to biochar that contains contaminants like heavy metals, so it's really important to carefully select those source materials.
So responsible sourcing is key. What else?
Another thing to consider is the energy needed for pyrolysis. While biochar production can be pretty energy efficient, it's still important to make sure that the process is powered by renewable energy sources to minimize its environmental impact.
Right. We don't want to create a new problem while trying to solve another one.
Exactly. And then finally, there's the issue of scalability. We've seen some really promising developments with large-scale biochar facilities like that one in South Africa. But to really meet global demand, we need to keep innovating and investing in ways to scale up production effectively.
It sounds like there are some challenges, but they seem like challenges we can overcome with research and innovation.
Definitely. And the potential benefits of biochar are just too significant to ignore.
All of this is really making a lot of sense. Well, this has been an incredible deep dive into the world of biochar. From the science to the stories and the future possibilities, it's clear that this is a material with a lot to offer.
Absolutely. It's a technology with immense promise for creating a more sustainable and resilient future for all of us.
Well, that about wraps up this week's episode of This Week in Biochar. We covered a lot of ground today, from the latest research to inspiring stories of innovation and impact.
It's been a pleasure talking biochar with you.
If you're as excited about the potential of biochar as we are, be sure to check out the links to all the articles we discussed in the show notes. And join us again next week for another deep dive into the world of biochar.